All right, so this is the first lecture of week 1 um, of data mining and warehousing. We're going to talk about data. We want to know our data because when we are doing data mining, we will be working with data. So we will get to know what is data, what are the types of data, what are the different representations of data. So for today's lecture, for the first hour, we're going to talk about data objects and attribute types. And for the second hour, we're going to talk about basic statistical descriptions of data. Now, the two topics are related. In order for us to be able to how to represent and how to describe data, we need to know the different attribute types or the different types of data, because once you know that, you will directly be able to know what is the best way to describe these types of data. So what is a dataset? A dataset is normally made up of data objects. Okay, so we call a data set as a set of objects, and each data object is represented by an entity. So these are data objects. Okay, all of these are data objects, and each data object is represented by an entity. So this is an entity. In the language of tables, a data object will be the set of rows, or the data set, okay? And the entity will be one single row, okay? Now, for each data set, we have a list of attributes, and attributes are considered the way for us to describe the object. So from the example here, refund, or let's say transaction ID, is an attribute. So this is an ID that describes an entity, okay? And these attributes will have values. So transaction ID has numerical values. Refund has a yes or no values. Marital state has a single, married, divorced values. Taxable incomes has a numerical value, which is an integer, okay? And cheat will also have a yes or no value. So these are attributes, these are objects, and these are entities. And each of these are considered to be attribute values. So an attribute is a property or characteristic of an object. And example, this is a different example from the one here in the table: eye color of a person, temperature, etc. And also the attribute sometimes is called as a dimension, or as a feature, or as a variable. So refund here can be called a variable, or it can be called a feature or a dimension. Now, if we have a collection of attributes, we'll be able to describe a data object, okay? Now, an object can also be called sample, or example, or data point, or instance of data. So what is a data set? A data set is made up of data objects. Data objects have attributes. Attributes have values. Now let's focus on attributes. So an attribute, or a dimension, or a feature, or a variable is actually a data field representing a characteristic or feature of data object. Now, the attribute is actually describing the data object. So if we have an object of a customer and we want to describe this customer, so it will have these attributes. It will have customer ID, its name, its address, its age, okay, its or date of birth. All of these are attributes that will be describing the customer object. Now, attributes have different types, okay? They can be nominal, they can be binary, and they can be numeric. And we're going to explain each one of them in a minute. So we're going to talk about nominal, binary, and numeric. And numeric is sometimes called or named as quantitative because they represent quantities, numbers. Okay, and the numeric type have two subtypes, has an interval scaled or a ratio scaled, and we will differentiate between these with examples in a minute. Now, nominal data types are sometimes called as categories, okay, and this is when we have an attribute of a nominal data type, it will have values that are naming things. For example, here, hair color, auburn, black, blonde, brown, gray, red, white, whatever. So we have a finite, which means that it's a limited set of values that are assigned to this attribute. These are the values that are possibly can be assigned to hair color. However, nominal attributes or categories do not have let's say importance over each other. So black is not more important than brown, or gray is not more important than red. Okay, they are equal in importance. Okay, so if you say a customer has a black hair, that does not mean that this customer will have more importance or more value compared to a customer that has a gray hair. Okay, same goes for marital status. Single and divorced and married do not have preferences. They're not. You cannot arrange them. You cannot arrange the customers based on their marital state. They're only describing their marital state. Same goes as occupation, ID numbers. Having an ID number of 55 does not make you less than this person who has an ID number of 1. Okay? So this is a nominal attribute or a nominal data type. The second type is binary, and the word binary usually means either or. Okay, so when we say that a binary attribute type, we're talking about two states. Okay, it's either 0 or 1. So it can be a male or female. Okay, it can be positive or negative. So in this case, we have only two possible values. It can be yes or no. Okay, so we have only two possible values for the attribute, two states. And within the binary attribute type, we have two subtypes. We have symmetric binary and we have asymmetric binary. Symmetric means equal. Okay, so if you say male or female, these are equal binary types. There is no preference between male or female. However, asymmetric binary is actually they're not equal. So for instance, if it's a medical test, a coronavirus test, positive and negative are not equal. Negative is better than positive. Okay, now how is that different when we represent them? Now, if you are representing a symmetric binary, such as gender, okay, you are free to pick, if you want to represent it as numbers, you are free to pick 0 or 1 for either or. So you can say 0 for male or 0 for female. It doesn't matter because they are the same thing. However, when you are dealing with asymmetric binary attribute and you want to give it numerical value, in this case, you assign 1 to the most important outcome. Okay, so if you are focusing on HIV, which is AIDS, حمانا الله HIV test to be positive, and this is what you're focusing on, so you will assign 1 to HIV positive. However, you'll be assigning 0 to HIV negative. The third attribute type is ordinal data type. And to really remember ordinal, what does it mean? Ordinal is coming from the word order, okay? Now, the ordinal data types, they have meaningful order. They have ranking, okay? So, the first thing is that they have ranking, they have order, okay? However, the magnitude or the amount between two values that are coming one after the other is not known. For example, small, medium, large for a let's say a dress or a t-shirt, or grades when you say that A, B, and C. Okay, so A can be anywhere from 90 to 95. B can be anywhere, B can be from anywhere from 80 to 85. So you can say that this one is A and this one is B, but the exact difference between them, you don't know it. You know that the order, that the one who got A is better than the one who got B, but you are not exactly, do not know the values between them. So this is ordinal data. Okay. Now, numerical attribute types. For the numerical attribute types, we said that it's about quantity. Okay, so it's about numbers. These numbers can be integers or real numbers. Integers as 1 to 1000, minus 1000, or real valued, which will have a decimal point. Now, in this type or numerical type, we have two subtypes. We have internal and we have ratio. And for both, they are both numbers. However, the difference is that the ratio data type does not have does have a zero reference, a reference point. And the interval does not have a reference point. Now, when we talk about in Celsius or in Fahrenheit, first of all, they do have an equal sized units between them. So if we can say it's currently 12 degrees Celsius and later on it will be 20 degrees Celsius, we know that between 12 and 20, it's 6 degrees Celsius, which is equal the same as between 20 and 26, 6 degrees, okay? Same goes for dates. So we know that there are fixed intervals. A day is a day is 24 hours, an hour is 60 minutes, etc. So these are fixed sized units, okay? The ratio has the same thing regarding the equal sized units. So the difference between them is clear. Now, with the Celsius, degree Celsius or Fahrenheit, we say that there is no zero reference point, because when you go to 0 degrees Celsius, you can also go to minus 10 degrees Celsius. You can go to minus 20 degrees Celsius. Same goes for calendar days, because you can go to year 0 in the calendar, but you can also go before, if we're talking about the Gregorian, which is based on the birth of Sayyidina Isa alayhi salam, we also have dates before that. So we do not have a reference point. However, for ratio data types or attribute types, we have a zero reference point, because you can have you can have 0 speed, but you cannot have -1 speed. You can have 1 year of experience, but you cannot have -3 years of experience. So this is the difference between the interval and the ratio attribute types, numerical attribute types. Now, what we just mentioned are a different categorization of attributes. This is a second categorization of attributes. Okay, it's not. It's like we first classified them based on the data types and their characteristics. Now we're going to describe them based on their continuity. Okay, so attributes can be either discrete or they can be continuous attributes. So discrete attribute has only a finite or countably infinite set of data. Okay, so we have a set of data that are can be counted. They are limited. So we have zip codes. Maybe we're not familiar with zip codes, but let's say professions. Eventually, we have a finite set of values for the profession. We know, you can be a teacher, a lawyer, and the list is limited at the end. The set of words in a collection of documents, no matter how big this collection of documents, eventually it is limited. Okay, now discrete values sometimes are represented as integer variables because you can count them. Okay, they're limited. Okay, now if you think about the binary attributes that we just discussed earlier, when we have only two possible values, this is considered to be an example of, or a special case of, a discrete attribute. Continuous attributes, on the other hand, you can think about them just like the real numbers. So the numbers between 0 and 1 are infinite. You cannot really think of a limit between them, because there is always a way or a room of a fraction between these numbers. Okay, so continuous attributes are actually usually represented by real data or floating point variables, and discrete attributes are represented by integer variables. Now, we covered the types of attributes. Now we're going to talk about the types of data sets. How do usually data sets look like? So we have record data sets, we have graph data sets, and we have ordered data sets. And we're going to discuss each one of them in a minute. Now, record data sets have all of these are considered record data sets: data matrix, document data, and transaction data. And graph data sets, these are considered also example. However, we'll be focusing on the World Wide Web here as an example of graph data set, and ordered data set, and we're going to talk a bit about genetic sequence data while explaining a bit about spatial and temporal data, or time series in particular. Now, record data, the first thing that comes into our mind when we talk about that record data is it's represented in the form of table. Okay, so it's a collection of records, and each one of them has a fixed set of attributes. So here we have a transaction ID, and it has a fixed number of attributes that is present for all records. So record data are usually represented in a form of a table, and this is the conventional data that comes into mind once we think of a data set. This is how we imagine a data set. A second type, which is also a subtype of record data, is a data matrix. Now, data matrix is actually also is considered as a set of records. However, the attributes, the values that are represented here are all numbers. Okay, so if data objects have the same fixed set of numeric attributes, then the data objects can be thought of as a point or in a multi-dimensional space. So thinking about it, if you have an entire record that consists of numbers, this means that it can be represented in a multi-dimensional space. And this space will have or will be represented by an M by N matrix, where M is the number of rows, which is here 3, and N will be the number of columns, and it's here is 5. Okay, and if you think of it, let's just ignore these 3 and think of these here. So we have this is a 2 by 2 matrix, and this can be represented in an XY dimension, right? An XY dimensional space. If we add a third one, it can be represented in an XYZ dimensional space, which is a 3-dimensional space. However, we are not able to imagine a 4-dimensional space or 5-dimensional space, but the computer is capable of doing that. That's why a data matrix is considered as one of the types, the dataset types. A third example of a record data is actually document data. And in this case, we actually think of each row is represented by a document. And this document can be, let's think about it as a Word document. Okay? Each document is represented by a row. And this row here is called a term vector. Okay? A term vector, we call it a term vector because it consists of terms. Okay, so document 1 consists of these terms, okay, and these numbers represent how many times this term occurred in document 1. So in document 1, we read the word teams 3 times, nothing coach. Play, we read it 5 times, nothing ball. 2 for score, 6 for game, 0 for win, 2 for lost, timeout 0, season 2. Okay, so it's actually, we are summarizing the document in terms of numbers. We're saying that document 1 can be summarized using this term vector. Same goes for document 2, same goes for document 3. As I said, this can be a Word document, a PDF document, an HTML document containing text. We can also have a transaction data, which is a special type also of a record data. Each row represents a transaction. And this is an example of a transaction which is about the purchases. So for transaction 1, these are the items that were purchased in this transaction. However, transaction data will give us more example, not only about the transaction will have only bread, Coke, and milk, but we are able to know about the quantities of these items, the prices of these items, and these can be utilized and used in further analysis. We also have graph data, and graph data, the perfect representation of graph data, in my opinion, is social media data. Let's say Twitter data. So we're talking about a certain account, and you can represent the number of, let's say that this account is followed by, let's say, by this account, and this account is following this account. Let's ignore these numbers, and I will let you know what does it mean here later. So this account is followed by this account, and this account is following this account back. Okay, this account is following this account. However, this account is not following this account. So this is what graph data is, and it is very important in representing social media relationship. It's extremely important in this area. However, this graph here is actually representing links. It's showing each page, okay, how many times is including a link to another page. So this page and this page, each one of them have each other's links 5 times. Okay, and it's important to know graph data. There is a language and there is a special databases that are called graph databases that are used to save this kind of data. The final type of data sets is ordered data, and ordered data is important because their sequence is important. And the most obvious example of ordered data is the genome sequence. The genome sequence is how our genetics are represented in our DNA. So the order is important, okay? So A and B, they should come in this order, and then D, and then C, and then E, and then B, and then D, in this exact order. And it is considered to be important representation of data, especially in time series data. Now, in time series data, let's think about it like when we are talking about the temperature within a month, okay? The daily temperature within a month. So the first day we'll have the temperature is, let's say, 22. The second day is going to be 25. The third day is 22. Now, notice these values, 22, 25, 22. They are important because they represent an order, okay? And they need to come in this order in order for us to utilize them. I will stop here for the first hour, and we will continue with our discussion and about the types of attributes and the types of data sets, and then we move to the second part in the next hour.